Okay, so this week's experiment is the oxidation of benzophenone using iron nitrate. The last thing we're going to do is recrystallize it, but I just thought I'd show you this quick time lapse of recrystallization because it really is quite a nice experiment. This week's reaction is also a little bit quirky. Last week all our reagents were liquids, this week they're all solids. So let's weigh out our ingredients. Diphenylmethanol, 1 gram, and iron nitrate, 2.4 grams. And then we're going to heat them up. We're going to add the iron nitrate in and put it onto the hot plate that's at 150 degrees. It's important to do this in the fume hood because it's going to make noxious fumes. So don't do this outside a fume hood if you're trying to repeat it elsewhere. Add them together, put it onto the hot plate, and immediately they'll both start to melt. If we look at that from the other angle, you can get a better look of what that melting looks like. This is sped up quite considerably to save us a little bit of time, but you'll notice that it starts to turn brown as it turns to liquid. There's a few reasons for this, but one is because it's producing N2O4 or NO2. NO2 is a brown noxious gas. You do not want to breathe that in, so again I emphasize, if you're going to do this, do it in the fume hood. Once it's entirely liquid, then it's time to add in our final solid reagent. We're going to add in silica gel. Silica gel has two roles in this reaction. The first is that it acts as an acid, so it promotes the reaction itself. But the second, and sometimes more important, is that it absorbs all the material onto the surface, allowing it to react together. Because you'll notice before you add the silica gel, the two liquids don't mix. And so the silica gel allows the two liquids to mix. So we put in 2, maybe a third spatula, and then stir it till you get a reasonably good powder. And you'll see it's already starting to evolve brown gas. Of course, I've sped this up. This is going to take you a little bit longer. Once we've got it nicely stirred so that it's a smooth brown orange powder, then we can put it back in the hot plate and start to wait. And we're going to come back in about 10 minutes and stir it again, and then again in 10 minutes and again in 10 minutes more. Again, from the reverse angle, apologies for the in situ lighting, but it does help to see it. And you can see as soon as I start stirring it, brown gas starts coming out because the reaction starts. So stir it until it's a nice, reasonably smooth powder, and then leave it go. While you're waiting for this reaction to happen, and you'll be waiting a little while, you can see the time lapse here as it evolves, changes colour, becomes browner and browner, and we stir it every 10 minutes, and it's just a waiting game. But as you're doing this, what you can do in the meantime is you can measure the melting point of the reference materials in the lab, and you can also do your calculations. So calculate out what your theoretical yield is going to be. Once we've gone through our half an hour, you'll see that it starts to get a deeper and deeper brown, and every time you stir it, it'll continue to evolve gas, and then once half an hour is gone and you stir it, very little gas should be evolved. And again, you can have a look at the reverse angle. You can see that as it heats up and as the time passes, you get a fairly consistent dark brown solid. So once we've done with that, what are we going to do? Take it off the heat, let it cool down, and add in our ethyl acetate. And the ethyl acetate is going to pull our product off of the silica gel. Then we're going to filter away the silica gel. Before we use the filter, add in a few drops of water, and it'll make the silica gel less powdery and less inclined to go all over the place. Also, it's important to wet the filter paper before you start filtering, and make sure the vacuum is on it before you start filtering, otherwise it'll just go underneath the filter paper. We can filter it, and on the other side then we can see that we've got our ethyl acetate, which has slightly discoloured yellow product in it. So now what we need to do is get our product back. To be sure we get all of our product off the silica, we can give it an extra rinse with a little bit more ethyl acetate. Again, swirl it round, filter it through, and the very next thing we're going to do is get rid of that silica. So that stuff goes in the waste container, the very next thing. And now we can move on with our experiment. So we've cleaned our beaker, we're going to put our ethyl acetate into that beaker, so take off the vacuum tubing and transfer the liquid into the beaker from the Buchner flask. Add in a little bit of magnesium sulfate. Usually 1 spatula tip will be fine. You can tell when you look at it, if there's still lots of water floating around the bottom, that you haven't used enough. The solution should go clear. It should remain yellow but clear. And then once you've done that, we're going to decant that into an evaporating dish. Before you put it into the evaporating dish, it's a good idea to weigh the evaporating dish. That way you can tell how much crude product you have when you're finished with this. So decant it into the evaporating dish, nice and gently, leaving your white solid behind, and then we can put it onto the steam bath and evaporate it away. It's very important at this point that you choose to put it onto the steam bath and not the still hot plate, because a hot plate is so hot that it might catch fire, whereas the steam bath is safe, since there's only hot water around and the heating element is below the water, so the surface is never going to be above 100 degrees. So I put it onto the steam bath. Again, be careful, there is hot steam coming out of that, so you got to be a little bit quick. Put it on and wait a few minutes. And if you had sense, you'll have labelled it. Flasks love to be labelled. And if you come back and there's 11 other full positions, you better be able to tell your one apart. So don't forget to put a label onto everything that you leave behind. Wait a few minutes and all the solvent evaporates, and what you're left with is a brown oil. And that brown oil is mostly your benzophenone. There's some things discolouring it, but for the moment that'll do for a crude product. So that's what we've made. If we want to get that back as a solid, then we've got to cool it down. So let's put it into some ice. Take your product, put it into ice, and wait a few minutes. And often it'll crystallise or solidify all by itself. Sometimes it won't though. And if it won't, we can help it on its way. So to help it on its way, we just take a sample crystal and the whole thing will go from liquid to solid. That's sped up a little bit, but it's a fairly dramatic change and it happens fairly quickly. Now we want to recrystallize our material and get rid of that yellow colour. So what we can do, and in your procedure you're going to not do this in the evaporating dish, but I've done it for the sake of time. Melt it in a little bit of petroleum ether, add in some charcoal. The charcoal will remove the colour. The coloured components stick to the charcoal. Stir it around and then filter it. And if you're going to filter it, you've got to filter it through a hot funnel, because otherwise it'll start to crystallise as it goes through the funnel. So stir it, heat it up to the boil, and then take it back off again. And then in your pre-prepared heated funnel, which you've heated over on the hot plate, and your fluted filter paper, and it has to be fluted, what we're going to do is filter it. And then if you take that and you put it into ice, eventually crystals will start to form. So to finish out here, here's a few other images of benzophenone solidifying. You can see in these first two that my product is not so pure. You can see in this that I've got exceptionally pure product, and the slightest scratch on the glass initiates crystallization. And if we wait for this time lapse a little bit longer, what we see is the whole thing turns to crystals. Okay, that's nearly it for this week. The very last thing then is fluting a filter paper. So this could be a separate video of itself, but if you want to practice, take a round sheet of paper, make a round sheet of paper, and try and flute it. And you might ask yourself, what is the point? Well, the more surface area of your filter paper that your solution comes in contact with, the faster it can get through that filter paper. And if you're heating your funnel up to try and keep your solution hot as it goes through, you want it to happen as fast as possible. So it's worth learning to do this. So fold it in half again, and that's what you get. Now fold one of the corners back. So you fold one of the ears back, like so, and then you do the same on the other side. You fold the other ear back. And that'll look something like what you're about to see now. The next bit then is a little bit different. So that's enough folding in half and folding in half again. Then you take one of those corners and you fold it back, and it'll look something like that. And what you do is you follow that so that it goes across and back and across and back regularly. And so you do that across and back and across and back until you've got 8 little segments that are all regular and the same size. And then you do that all again. So you take one of the edges, it's going to look something like that. You take one of those edges and you fold it in half, and then you follow that half across and back and across and back and across and back until eventually you end up with 16 folds going through it. And at this stage then, what you'll have is a nice neatly fluted filter paper. It takes a little bit of practice, and the first time you do it, it'll take you a few minutes. But it's really important to do it, because if you don't, your experiment won't work as well. You'll lose more material in the filter paper, or at the very least you'll be waiting longer for your solution to filter. Alright, that's all for this week. Any questions? Post them up on Moodle, post them in the comments below, or just ask in the lab. I look forward to seeing you there. Bye!